Hello and good morning, everyone. My name is Paul Spanburg. I'm sales manager at Lumitronics, and I'm welcoming you today to our webinar called Revolution of UVC LED Efficiency. We today do experience some technical problems since I have been placed into quarantine just today. So I have to hold this webinar from a different place and with different hardware than it was intended to be. So please excuse if we do have some little technical issues in the meanwhile. I hope everything will anyhow go pretty smooth. This webinar will be recorded and you will have the opportunity to download the recording after the webinar. You do have the opportunity to put questions at the question and answer area, which you can find at the small question mark on the upper right corner, it should be. Please just put your questions while I'm doing the presentation, and we will try to answer the questions after the presentation. We will also give you the opportunity to download the presentation and also to request references which we will have within the presentation, but which we cannot show in detail within the course of this 20-minute presentation. So I will try to jump into the presentation. Okay, so I assume everyone can see our presentation now. As I said, due to the due to the different technical arrangement over here, everything will not go just as smoothly as I am used to, but it should work. Our agenda today is that I will shortly introduce our UVC activities at Lumitronics to you, and then jump into the revolutionary improvements of the LED UVC technology going on just right now. I will take a look at Moore's and Hyde's law, just to give you a little background on what we are assuming our estimations on, then jumping into the efficacy forecast, price forecast, and then giving a little insight into wavelength considerations and lifetime presumptions for UVC LEDs at the current situation. Afterwards, we will take a look at the applications opening up to UVC LEDs. We will take a look at research projects, which we are doing at Lumitronics together with several different Fraunhofer institutes, and take a look at the applications in surface disinfection, air cleaning, and fluid treatment, which will open up in the future if the LED efficacy is greatly increasing and at the same the price is dropping significantly. We at Lumitronics are doing soft and hardware development of light sources. We do manufacture this light sources in-house, and we are partner of market-leading LED manufacturers, specifically also in the UVC area. We do cooperate with research partners, specifically also Fraunhofer Institutes, IBP, IGB, and IPA. And we do have plenty of experience with LEDs. We work with LEDs since 2005 already, and our UVC activities range back till 2018, and UVA experience reaches back until 2011. Our core competences are to develop electronic circuits and embedded software and do the electronic manufacturing service and mechanical assembly for those electronic parts for those light sources. And we are also distributor of LEDs, lenses, drivers, and so on for UVC technology. We are not a simple distributor. We do have a lot of knowledge and background on UVC technology, and we are getting that from deep technical research on the function of the light sources we are producing. Okay, let's jump a little into the theoretical background of presumptions we are doing. So you likely know Moore's law, which is an observation of the doubling in numbers of transistors in a dense IC every 2 years, which has proven to work out pretty well within the last 50 years already. And there is the Heights law called, which is the LED counterpart kind of Moore's law, which predicts price fall by factor 10 every decade and an increase of light output by factor 20. And this has proven also over a long time to be valid, and has proven to be valid also for different kinds of wavelength, from red over to blue, and also UVA. Similar observations have also been made for other semiconductor-based technologies, and we assume that UVC development might follow a similar path. So this is not a real physical law, actually. It's just an observation of the development of this technology, and it allows us to have some presumptions of the future development. So about the efficacy, we have gathered a lot of data for red LEDs, blue LEDs, UVA and UVC LEDs, which we're showing in this graph. Red LEDs had been the LEDs developing the first from the 1970s already, growing into a matureness already in the 90s, late 90s, beginning of 2000s. And blue LEDs and UVA LEDs have followed a similar path just a few decades later. And for UVC LEDs, I'm looking at 275 nanometers right now. We are seeing a development which is in a very, very early stage, but which might follow up a similar direction in the future from what we are seeing in the market right now. You can get the historical data on which we are basing our graphs, which we are showing, and also our Lumitronics estimation for the future afterwards in a data set. I cannot show all this data right now because it will just blow up the time for this presentation. just as interesting as the development of the efficacy, in our opinion, is the development of the price. We have done a comparison to UVA LEDs, which have started to develop in the early 2000s and gained speed since 2010 approximately. You can see that approximately at 10 years from now, in the past, so 2010, 2011, the price level for UVA LEDs of 365 nanometers was pretty similar to what we can see today at UVC technology. But the price you had to pay decreased a lot. So today we can get 1,000 milliwatts approximately at €1, and at UVC technology you only get 12 milliwatts at €1. But we see that the price decrease might follow a similar pathway also for UVC technology in the future. What is also very interesting and very important is the wavelength consideration. So we at Lumitronics are mainly working with 275 and 280 nanometers at the moment, but we do see a strong trend towards a lowering of the wavelength from 275 or 280 towards 265 nanometers. And increase of efficacy at the same time. This will help several applications to generate a total efficacy for the application, which is higher than it is right now, because 265 nanometers will have improved efficacy towards the application compared to 275 or 280 nanometers. Very important is also the lifetime presumption, which is worth looking into right now, because what we can see in the market is that several different LED producers are offering very different LED efficacy, but the lifetime is also very different. Currently, you can get a range from approximately 2% efficacy up to 7-8% efficacy, but the difference in lifetime results primarily from the package quality, and the package quality varies a lot from one producer to another. So it is very important to also look into the lifetime, and we do expect mostly all producers to be able to increase their lifetime within the future, maybe 12-24 months, significantly by improving their package quality. Okay. So this is for the moment all into our future presumptions. It would be great to get into touch with you after this webinar to discuss more in detail what this might mean towards your application, and we will gladly offer you to give you more information and background information in detail towards why we think this development might occur in this way, because we think at the moment it is the right time to start development for applications which are not able to be developed right now or to be put into the market right now, because pricing or efficacy are just not good enough right now. I would like to give you a little background on what research projects we're working on right now. So firstly, we are cooperating with the Fraunhofer Institute's IBP, IGP, and IPA in the so-called Healthy Air Initiative. It is an initiative funded by Ministry of Economy of Baden-Württemberg. and it is supposed to help the industry and help especially schools, kindergartens, or other such areas to improve the situation with the coronavirus, to have a cleaner and safer environment. We are analyzing air cleaning system, which we have developed at Lumitronics with UVC LEDs. This air cleaning system is a customer's project where we're using a filter plus UVC LED with a volume of approximately 200 cubic meters per hour. The measurement is being performed with a coronavirus surrogate, so it's not actually coronavirus because the handling of the coronavirus is highly difficult. It is a Phi6 virus, so with a size of approximately 120 nanometers. It is RNA containing, but non-pathogenic. The testing environment in this test is pretty much simulating a real condition with a 40 square meter room area. There are 6 particle counters spread in the room and 1 air sampler. It is not a testing condition with a very, very small area and with a very, very small airflow. It is a tricky testing condition to get really good results. Our results with our air cleaning system show up to log2 reduction of this coronavirus surrogate at standardized testing conditions, which is a pretty good result in our opinion. Because we are only putting an optical power of 70 milliwatts at 280 nanometers at the moment. There is, of course, no ozone generation included in this test. So the second research project in which we're cooperating with the Fraunhofer Institute IGB and IBP is called Competence Center for the Assessment of Products with Ultraviolet Sterilization. This research focuses on surface disinfection, and we are using a supermarket called Beckesep in town Sölden, where we are analyzing the result of surface disinfection on fruits and vegetables with UVA radiation and the surface disinfection on EC card terminals with UVC radiation. This research is still ongoing, so I cannot present any results at the moment. The Fraunhofer Institute will do the simulation, material testing, germ growth, and validation. We are expecting to have pretty interesting results, also due to the testing of UVA radiation in combination in one application with UVC. We expect to get results until the end of the year or beginning of next year. So if you'd be interested to get more of these results, please keep in touch with us. So what applications do we see to be coming up in the future? Firstly, we see that home appliances might be able to implement into the mass market already on a very short term. So specifically water tanks, treatment of fluids in small scales, self-cleaning systems are already possible to put into the market with the technology as it exists. There is a very high run on air disinfection systems due to the pandemic situation, naturally. So at the moment, there's happening a lot in this area, and also there is happening a lot with UVC LEDs. But very honestly, the efficacy of LEDs and the pricing of LEDs is currently too high to generate a very high effectiveness of the total system. So in the end, we see that air disinfection is still a topic for the future, and we will greatly increase the efficiency of the systems by increasing the efficiency of UVC LEDs. For the midterm, we see that the food industry will be a very, very important playground for UVC LEDs. There can be increased shelf life. The production of packaging can be supported with the UVC disinfection. Cleaning and recycling is a very, very important topic, since we all know that we need to produce a lot less waste, and within the cleaning and recycling processes, UVC disinfection will play a very important role. And naturally, product safety is important in the food industry. On the long term, we see that water disinfection will come up. So water taps, or also on the very long scale, 5 years plus, municipal water treatment might be coming into a possible range. So to stop my flow in talking, we have arranged a little test, or our trainees have arranged a little test with UVC LEDs, which they would like to show to you, but it is a little tricky to show you due to the technical problems, but I hope it will be possible. Just a moment. Frederick, can you switch on your camera? Great. So I will show you. I will switch on the camera now, right now. Yes. Okay. So I'm explaining to you what Frederick, who's training in our hardware development, is showing to you right now. This is just a very small experiment which our trainee has done to just show you how easy and with how little cost it is possible to actually put UVC technology into use already right now. So what Frederick has done is just to use a plastic box, where you put your food inside, and he has actually put a sandwich inside, and let this sandwich stay over a course of 5 days right now. And yeah, what you can expect from the sandwich is that it starts to rot, of course. Or maybe Frederick, you can show if we can see already some results after 5 days. Yeah, okay, so we got a little fungus already on the top. It's not looking that bad, but I wouldn't recommend eating it anymore. Thank you very much. And in the second installation, so it's the same sandwich made at the same day, Frederick has just included one UVC LED on the top of the box, which is just supplied with a very small USB-C adapter. So the total installation cost for this is approximately 10 euros. And if you open the box, I hope we don't have any fungus. Yes, so it looks quite good. So this is of course not any kind of scientific experiment of any kind, but it just should show you it is very, very easy to see the actual result of UVC LEDs, even in small scale applications, and at very, very low cost. So for a distance like this one. So there's a distance towards the sandwich of just a few centimeters. Even a UVC LED with very few milliwatts of optical power output, this one has less than 10 milliwatts, can generate a very, very good result. Okay, we just lost the picture. Okay, let's go back to the presentation. So okay. Sorry, that was the wrong presentation. Sorry very much for the inconvenience. Usually I should have 3 screens, which makes it tremendously more easy to handle this. Right now I do not have 3 screens, and that makes it a little more difficult. So, okay, but now finally you can see our presentation again. At the point where we stopped just now. Thank you, Frederick, again for your little experiment which you performed and showed to us. I hope this helped to give us a little insight into possible practical applications. So we have seen a very, very easy surface disinfection example right now from Frederick. We are doing research in this campus UVC together with the Fraunhofer Institute to actually find out possibilities for professional installation in supermarkets. And we think the technology is already ready for the market if we are looking at surface disinfection, because the radiation intensity of conventional UVC sources with just 25 to 30 milliwatts per square centimeter is actually far lower than what you can achieve with UVC LEDs at the moment. You can get a 500 to 600 milliwatt per square centimeter at the moment, which is approximately 20 times superior to what you can get with conventional UVC sources. But there is a large problem with that. The low efficacy generates a lot of heat. So if you want to actually use radiation intensity of 500 to 600 milliwatts per square centimeter, you'll need to handle 23 watts of thermal power per square centimeter, which makes it very, very difficult and which makes it unlikely to use such high radiation intensities with UVC LEDs in the application right now. So what we can see in the real world application right now is that far lower UVC radiation intensities are being used because heat generation can just not be handled. If we look into the increase of the efficacy in the future with increased efficacy by 2, 3, 4 times within the next years, it will be very, very much more easy to handle this thermal management problem. For air cleaning systems, we can see in the Healthy Air Initiative that our testing results show up to log2 reduction with only 70 milliwatts. But it is a combination of filter plus UVC light. We do currently have a reference design for air cleaning system with 2.5 watts optical power, which we can also share to you if you'd like, and get into touch with us after this webinar. But also this system is just reducing, doing a log3 reduction at 5 liters per minute, which for air cleaning system is not as much as you'd like to have for larger rooms. So for a high system efficacy of log3 or higher with a high airflow rate and no extra filter systems, the optical power must be significantly higher. So we're talking about optical powers of 10 watts or more, which are demanded for such systems. These systems can actually be built in terms of heat generation at the moment. That is not such a big topic in the air cleaning, because usually you do have plenty of space. But the pricing is just too high to actually put such systems to the market right now. But with a decreased pricing by a factor of maybe up to 10 within the next years, we do see possibilities to penetrate the market in a lot of fields with air cleaning systems. So last but not least, for the very far future, we see that the fluid treatment is the main future perspective opening up right now. We do have reference design for small quantity water treatments at the moment with a size of 5 liters per minute, and water tank reference design for example, coffee machines or other household goods with up to 10 liters of water tanks. But these are very, very small scale numbers if you're talking about fluid treatment, especially in the food industry. You'll need far higher rates of flow to actually generate any kind of actually usable, industrially usable technology. And if you're looking at a municipal water treatment, the flow rates of water need to be by a factor of hundreds or thousands higher. So what we need to penetrate that market is higher efficacy and lower price at the same time. And but we see that this market will open up within the next 5 or maximum 10 years. It might be the right timing right now to go into the development of products. So summing it up, the revolutionary changes in efficacy will unleash the full potential of UVC LEDs, and we see this starting right now. We strongly ask you to approach us right now to talk about your future perspectives and your applications, because when the time is coming that application is actually possible in terms of efficacy and in terms of pricing, then likely it will already be much too late to start the development of such products. We see that a very high dosage due to the high radiation density with LEDs is already now better than with conventional light sources. You have better beam shaping possibilities. You can do a combination of wavelength and create very good technical results due to that. With LEDs, you'll be able to enable also mobile and fast automated applications, because you do not have the problem of switching cycles, and you do not have time to wait until the light is completely on. LEDs are very robust against physical stress and should have a far longer lifetime in the future. though at the moment this might be a problem yet. Definitely one of the main benefits for LEDs is they are environment friendly, so you do not have mercury, you do not generate ozone with the usage, and therefore you'll be able to create a real sustainable technology for your application. In the end, LEDs are very, very useful compared to classical UVC products, because you are truly able to create intelligent UVC products, which are actually creating as little UVC radiation as possible, but just as much as needed to do the job. Okay, so thank you very much. I think we overspent the time a little bit. Sorry for the technical issues we had in the meanwhile. We are open for your questions right now. I did not have the possibility to check them until now. Let me see if we do have a lot of questions. So let us jump into these questions. Manuel Franke asks, is the increasing of the milliwatt per euro due to the increasing of the milliwatt or the dropping of the price? So this is not a question which can be answered with this or that, but it is both actually. So the milliwatt per LED will increase in the future, mostly due to the efficacy increase, and at the same time you will have the same component at a better price in the future. Then the next question, in the test room, in the test with the room in the Healthy Air initiative, where the virus is continuously being released in the room, how long did it take to achieve the log 2 in the test room? I can share afterwards the test scheme, which is a total of 3 hours test, first without UVC light and then with UVC light, but it would be too difficult to explain the exact testing scheme. So I would ask you to please leave us your email address or your telephone number so we can get into personal contact with you. The timing was approximately 30 minutes until the log 2 reduction was achieved, but the total test scheme is a little more difficult to explain. Jo Becker asked, what is the maximum distance between the lamp and the particles to be destroyed? Oh, that is a very difficult question to answer because it depends on the particles, so on the virus, bacteria, or whatever you want to treat with. All these particles will have a specific dosage at which they will show a specific reaction. And this dosage varies from one particle, from one virus or bacteria to the other. So this can be answered only looking specifically at one specific virus or one specific bacteria. And then with a larger distance, you have a reduction of the efficacy by physical law. So it is a square law. So with each additional distance, you lose one factor of efficacy. But we'll have to go into detail with your application to really give you a solid answer towards that. Next question is, what is the effect on human health by these light sources. The effect of UVC light on human health is very important to look at, because UVC light can be very dangerous towards humans. All applications we are looking at right now should always have a safety concept, must always have a safety concept, allowing a safe usage, which means that the UVC light should not hit any eyes or skin of humans at all. And if it is hitting, there is a specific dosage which is allowed to apply, and we can analyze your products together with you for the safety. The effect of UVC light on the skin or on the eyes can be very, very destructive and cause kind of sunburns within a short amount of time. The next question is, hello and good day. Thank you very much for the presentation. Currently, the development is that UVC tubes have 40% lighting power and UVC LED has currently only 2%. When do you estimate the LED development has reached the same performance? Is it possible to increase it if you use optics? Okay, this is a longer question. So firstly, what we see is that the efficacy of LEDs is not only 2% at the moment, but it is reaching up to 7% already. Right now, we are able to deliver systems with the efficacy of 7%. And we will be able to deliver systems with 10 to maybe 12, 13, 14% within the next year. UVC tubes have 40% efficacy. Okay, there might be UVC tubes which reach up to 40%, but what we see in the market is actually more a range of 25 to 30%. So to reach a same level of, let's say, approximately 30%, we see that it might happen until 2025, but it is just an estimation, to be very honest. The next question of Florian is, what are the risks to be expected with the UVC? So towards the human, I already said something about the risks, but what is also very important to consider is that there are plenty of risks towards materials just as well. So these risks might not be just as important as risks toward humans, but UVC light is very aggressive also towards materials. Specifically, plastics can be destroyed with UVC light pretty fast, so you might see effects within a few hundred hours already, and these are risks which need to be considered in the application, and which also stop some applications from actually being very useful. How can they be avoided? Mostly we try to avoid with our customers risks due to UVC light by just putting UVC light where it is actually needed. And that is very easily possible with LEDs because we have very, very good beam shaping possibilities, and LEDs are very small and we can bring them closely to the actual application area. So there's another question, if UVC sources from Philips are much more efficient. We have shown efficacy of one UVC lamp, which is a radium UVC lamp. The efficacy of different producers does vary. So yes, there might be Philips UVC lamps which are more efficient than radium UVC lamps. I actually not very familiar with the Philips or the radium lamps. So and there's also Osram and other producers. So there might be more efficient lamps just as well. Next question is Tero is asking why higher wavelength UVC LED have a better lifetime stability. This is mostly due to the material physics. The lower the wavelength, the higher the power of the LED towards other materials to destabilize them is. So it is just possible to create problems within the package with a lower wavelength because the materials will degrade much faster with a lower wavelength. Also with the lower wavelength, the transmission grades of materials get lower. So also the initial efficacy is mostly lower for lower wavelength. Next question by Miguel Ferrando. Are there any rules for the evaluation through assays of UVC efficacy in air and surfaces? Yes, there are guidelines and there are also some rules which are existing. So for the evaluation of air efficacy, we are working with the Fraunhofer Institutes in this Healthy Air Initiative, and they are using a standardized testing condition which is following rules set up by the German government to allow air cleaning systems to actually be efficient in usage in classrooms or similar applications. But to be very honest, the conditions for testing and the rules for evaluation are pretty new or not existent in some areas also. So this is still an area which is under development process right now. Which germ do you use to show the log3 reduction is the next question from Corbinian. Now let me think, which log3 reduction did you mean likely? Just a moment. Okay. So you are likely referencing towards the air cleaning reference design with the 5,000 liters per minute. This is based on a coronavirus, but it is not an actual test. It is just a calculation based on 10 millijoule per square centimeters. So there has not been performed a real testing situation with the coronavirus for this reference design. With coronavirus, it's also very difficult to perform testing. What can be the benefits of LED compared to HCl and CCl? I think I explained pretty much what benefits can be expected in the last foil, so I think I should not go into very much detail with with this question anymore. Just summarizing with 2-3 sentences very shortly. Of course, the long-term stability of LEDs should be far superior, and but the most important aspect is that you can implement small LEDs, fast switching cycles, 100% dimming possibilities into the application to actually generate the light needed for the application and not create any more harmful light for other surfaces or even humans with LEDs. The next question of M. Ernie is, do you have experience with the compatibility of plastics when exposed to UVC LED light? Yes, we do have some experience. This is an important topic also the Fraunhofer Institute is looking at in the campus UVC project, but it would be too vast field to go into detail right now with it, because all kinds of different plastics will have different effects with UVC light, and it also depends very much on the actual wavelength and the actual dosage of the UVC light. So if you do have some specific application and concerns about the plastics you're using, we'd need to dive into the technical details of the application to find out if we have some knowledge which can help you with this specific problem. The next question from Miguel Ferrando is, do you think that air disinfection systems are opportunistic due to SARS-CoV-2, or will they have a place in the future market? Well, naturally, it is a very, there's a lot of demand right now, which creates a lot of opportunities towards companies to fulfill it. So naturally, the situation we are seeing right now is in large parts an opportunistic development, but we see that a lot of, at least some of these systems are actually working pretty good and are creating a benefit towards the application. And from my personal perspective, I do not have the feeling right now that the topic which popped out during the pandemic will leave us any soon. So likely this market will have a future perspective. The next question of M. Ernie is, do you have any safe systems to protect the human eye from exposure to UVC LED light? It is difficult to answer this question because it is application driven. To make it simple, UVC LED light should not hit the eye. So within the application, safety measurements need to be taken that if humans are around, UVC LED light cannot penetrate directly the eye. Pretty simple. So if you cannot stop this, for example, in testing environments, then you can pretty easily create the safety for the user by just wearing glasses. Simple glasses will not permit UVC light to be transmitted. The next question of Simone is, the UVC work with direct radiation, therefore in the example toast box, the fungus goes in the rear and inside of the toast and not in the front, but the fungus still form. For this test, probably it's good idea to use UVA with a TO2 cell with a small fan, like a lot of refrigerators. Simone, yes, you're absolutely right. Of course, the UVC light can only have effect on the area where it's actually hitting. Yeah. So in the back of the toast, there will still be fungus. And I'd not recommend to eat both of these sandwiches. Um, the idea of this example was simply to show how easily you can see effects of the light in an application, but it does not mean that we recommend this simple type of application actually. Next question from A back is what would be a typical operational lifetime of a LED UVC module? So far, it was limited to approximately 1,000 hours operation when the LED or the PCB material degraded. Will this improve? Yes, definitely. And we see lifetime operational lifetime of UVC LED modules far higher than 1,000 hours today already. So we can create UVC LED modules which have L70, so 30% reduction of the initial brightness only after 10,000 hours. So 10 times as much as you would expect. The next question from Miguel Ferrando is, have you applied upper air disinfection? Is it safe? Upper air disinfection is a pretty interesting concept, which can be put into use in a pretty safe way because UVC light will not be directly visible. And reflections are not a big topic towards for UVC light because there's just no reflectivity in this wavelength area for almost all materials. There are materials which do have good reflectivity also for UVC light, for example, aluminium, but most materials will not have any reflectivity. Anyhow, we are not producing any final products like upper air disinfection, and the validation of the safety in the application will always have to be done by our customers. Next question is, to achieve 10 to 15% efficacy, it is just several percent, but double. Do you need totally new structure theory of semiconductor part? If yes, price reduction of current line will be reset. So the area of 10 to 15% is an area which will be available pretty soon. From what we see, 10 to 15% should be possible to deliver in a mass production scheme already 2022, so next year. If it is only 10 or more towards 15%, it is pretty hard to say right now. But so no, there's not a totally new structure or a totally new theory of the semiconductor part. The price reduction will continue just as it does right now. The next question is from Ajit. Is this technology accessible globally? What are the real-life business challenges that's affecting the proliferation of this germicidal technology? Yeah, so I think the technology is accessible globally. We are cooperating with several companies from around the world, so from Japan, from Germany, from the US. The real-life business challenges for LED technology are that very many applications are just technically not possible to use right now because the price is just not making it possible to actually market a product. And there are several applications specifically for fluid treatment where very high intensities and total powers are needed, where just the heat generation is not practically possible to handle. Going away from these two aspects, there is, of course, a third very important aspect, which is market acceptance. The market acceptance of UVC technology in many areas is difficult because UVC technology does have potential harmful aspects towards humans. We will be able to overcome these problems, first the two first problems, and then secondly also the market acceptance with experience and research. So we'll need to find out where and how we will be able to apply UVC technology to the application and where it is not possible. So you have seen a lot of pretty bad products within the last 1.5 years on the market popping up, really also putting humans into danger. And that must not happen. Next question. There's pretty a lot of questions. I think I'm going to cut it at some point, but let's see for 2 more questions or maybe 3 more questions. Is there an overview between wavelength and UVC and material types of plastics? I don't know of any real overview at the moment. We do have some bits and parts of knowledge. So we do have results for very specific types of plastic. So sorry, no, we don't have an overview. I'm not sure if any exists right now. What is the CO2 footprint of a UVC LED versus mercury tube for equivalent UV power? Very good question. I'd not be able to answer that right now. And we can look into that if it is possible to answer it. We'll come back to you if you leave us your email address. What we're also going to do is we have 24 questions right now, which we have published. We will publish all these questions with the answers in our on our website within a time frame of, let's say, 2 weeks, 3 weeks maybe. So the recording of this will be available within 1 or 2 days, and the FAQ will be available within 2 or 3 weeks. Next question from Achim Heberle. Are there efficient portable UVC lamps available or possible handheld? I'm not very sure about the actual availability on the market right now. There are pretty a lot of portable UVC lamps available on the market, but if I call them efficient, I don't think so. So possible, yes, possibly it is possible to build such handheld UVC lamps at the moment. Are they on the market? I don't think so. Yeah, okay, so we are through with our questions. It is already past 11, so a lot longer than we expected this to take, but it was great to get so many questions. It is great to have so many people viewing our webinar. Please look into our website, and you can download there this webinar, and you can also have our presentation files afterwards. Thank you very much, and hope to see you next time. Goodbye.